The broadcast is now starting. All attendees are in listen-only mode.
Well, hello everyone. Welcome to Coffee with Caleffi. Thanks for joining us today. Today we're going to talk about selecting and sizing domestic water heaters with Jody Samuell as our speaker. My name is Mark Olson. I'll act as moderator today. For those that see Bob often in this seat, Bob is on the road doing some training up in Canada, Quebec in fact, and I think he might be listening in perhaps with the group. So if that's the case, Bob, hello to you. Jody is a veteran with our Coffee with Caleffi series. He's our manager of engineering training. He's been on board with Caleffi for almost 3 years. Many of you I see on the attendee list probably know Jody already, as he travels quite a bit, meeting with specifiers, training them on applying hydronic and plumbing products into their applications. Prior to Caleffi, Jody was with other companies in this field, including Viessmann, including Antrol. He has served as a product manager and in training capacities in different positions. And before those experiences, Jody received a degree in marine engineering and spent 10 years in the Navy. In fact, quite a few of those 10 years underneath the water in a submarine. So I'm sure if you ever saw Jody in person, you'd have some pretty good stories to hear from him on. So with no more ado, I will introduce you to Jody. So Jody, take her away.
Thank you, Mark. A couple of things about the references for our discussion today. On the screen, you can see a screenshot of Hydronics 11 about domestic hot water. Great reference for domestic hot water heating. Highly recommend you get a copy of it, either hard copy or download as a PDF to read. The other thing is look at the information from the different water heater manufacturers. I spent quite a bit of time looking through the various resources that they have, and there's a lot of great information about water heating there among the various manufacturers out there. Now, let's talk about today's session. What are we going to cover? It's about sizing and it's about generating hot water. So it's about how much hot water does a building need? Balance.
Muted.
Want to burn enough hot water, but if I over-design the system, I end up adding a lot of cost. If I undersize, I risk my customer satisfaction. So I have to figure that. So when it comes to doing that sizing, how am I going to do it? Am I going old school with paper and pencil and a lot of cross-referencing to get to a point where I can specify a water heater? Or am I going to use one of the tools that a lot of the manufacturers provide nowadays to achieve that sizing? And we're going to look at a lot of these tools. There's some great stuff out there. And then we're going to look at the water heaters themselves. We're going to look at the pros and cons of the water heaters. We're going to talk about how the energy source plays into this. We're going to talk about designing for storage and recovery or just recovery alone. The one thing hopefully I have done as I've worked through, hopefully I can pull a lot of the manufacturer's bias out of the equation without throwing a lot of my own personal bias in there. You may see some of that reflected, but I'm sure we'll talk about that near the end. So, question always comes up. Doesn't matter the application, whether it's residential, it's commercial, it's a school, it's a restaurant, it's a hotel. I have to make sure that I meet the customer's needs with hot water. So the question always comes up, how much hot water does a customer need? Now, if I look at my residential customers, your average person needs somewhere between about 20 to 35 gallons of hot water a day. That's for showering, for cleaning. For guys, it's for shaving. It's for dishes. It's for laundry. But if I'm looking at meeting the needs, that's the amount of water I have to provide. Let's say I'm looking at a family of 4, and I'm going to go for a number somewhere in the middle. Let's say 25 gallons a day. For a family of 4 to meet their hot water needs, I need about 100 gallons of hot water. Now, when I look at that, that's not a very daunting number to produce. And as I start to think about it, it's like, boy, this should be really simple. the reality of hot water use in building. It's not a constant draw 24 hours a day. With hot water demand, there's peaks and valleys. There's going to be peak draw periods in some applications, in particular in residential. There may be stretches of hours where the hot water is not used at all. So when I start to look at it from an aspect of usage, daily knowledge isn't enough. Okay? This happens to be a typical peak and valley chart that came out of Hydronics 11. The red represents a high morning usage. The blue represents a typical high evening usage. But if you look at those bar graphs, hour to hour, the demand of hot water changes. And from a customer satisfaction standpoint, it's all about meeting the requirements on those peaks. Because if I can take care of the peak, then I should have no problems with the valley when it comes time to size that hot water. Okay. Now, residentially, it becomes a matter of how do I gather that information? This is a chart for peak load out of Hydronics 11. And this is a great chart to use if you know the demand in the building. There has to be a certain amount of specific knowledge. So you look at this, and these are actually off of DOE numbers for typical hot water usage. So if I look at that column for the use, if somebody's going to take a shower, they're going to use about 12 gallons of hot water during that shower. A bath, 9 gallons, so forth and so on. So if I'm looking at an application and I know how many times, and I'm going to go on a 1 hour period, that peak 1 hour, that they utilize this hot water, these hot water usages, I can calculate how much hot water at the peak my water heater has to provide. So for instance, this is also out of Hydronics 11 as an example. Let's say I have a family of 4, and I'm going to go with, like my family, it's an early morning peak. Let's call that peak between 6 and 7 a.m. in the morning. During that time period, there's going to be 3 showers. The 3 showers are going to utilize 12 gallons of water each, so that's 36 gallons of water. There's going to be 1 shaving in that period. 1 shaving used 2 gallons, I add that in there. Evidently, the 1 person that doesn't take a shower is going to shampoo their hair. That's another 4 gallons of water. And when it's all said and done, before they leave, I'm going to say somebody does a hand washing of the breakfast dishes. That's another 4 gallons of water. I add that all up, I get 46 gallons first hour or peak rating. Now, this is good, hard information that when I look at sizing my water heater, this is my requirement. And when we start talking about water heating requirements, usually, I should say ratings, water heating ratings are usually based on an hourly basis. So this is good information. Now, little side note, 46 gallons in this 1 hour period. If this was a family of 4, I'm looking at 100 gallons of water. So if I'm using almost half of the water in this one period, and I size and I satisfy that demand, the rest of the 23 hours should be easily satisfied as well. Okay. Now, the key is I need the data to utilize this chart. What do I do if I don't have specific data, or I'm doing an application that's much larger? Okay. Commercially, this is where the Hunter's curve or the modified Hunter's curve comes into play. Now, this method has been around since the 1940s. Hunter, I think it was Roy Hunter, was the engineer that developed it, and it's a way of estimating water usage, both for hot water, for cold water, for drainage. Okay. The first step in the process really is about what's called a fixture unit. Now, the fixture unit is not tied directly or doesn't correlate directly to a specific water demand. Okay. This table here has some example fixture units for things within the building. Now, I also added in a definition out of the dictionary of construction.com. It's a measure of probable demand on a water supply by a particular type of plumbing fixture. The value depends on the volume of water supplied, the average duration of a single use, and the number of uses per unit time. A lot of information, but if you look at that table, every fixture for hot, for cold, or combined has a value. Since we're sizing water heaters and I'm trying to look at demand on the water heater, let's look at the hot water side of things. So for instance, a bathtub has a fixture unit of 1. You know, a half bath group is a fixture unit of 0.5. So what these fixture units allow me to do is to look at all of the equipment in a building that utilizes hot water, assign a fixture unit to each one of those devices, and through this fixture unit, I can work my way to a water demand. This is where the Hunter's curve comes in. So you'll notice here, this Hunter curve, it's for various applications. It has a curve A for restaurants, a curve B, which includes my hotels and motels, curve C, apartment buildings, curve D, office buildings. So let's say I'm doing a motel, and let's say that motel has 100 fixture units, or FUs as I like to call them. I can enter into this chart with my 100 fixture units on the bottom, come up to my curve, go to the side, and I will get my gallons per minute. So for a motel with 100 fixture units, the resulting answer is the demand is going to be 34 gallons per minute. Now, if I'm going to kind of simplify the process, but if I take that 34 gallons per minute and extend it out to an hour, that's telling me that I have about 2,000 gallons per hour demand. But from this demand that I get from the modified Hunter's curve, I then have a piece of information that I can go and I can size my water heater with. The thing with this is like I'm at about the halfway point, because I still have to look at the water heaters that are going to meet this demand. So kind of a preview of where we're going. This is, with commercial water heaters, there's going to be about the continuous draw number. Now, a lot of times there's not a whole lot of data available about usage, or I may want to take a shorter route to get there. Now, residentially, a lot of manufacturers have charts available. I happen to pull up Amtrol's. I know the chart inside and out, and it's probably one of the charts that have been around in one form or another for one of the longer period of times. So this is a Boilermate chart, and the Boilermate is the style of water heater is what's called an indirect fired water heater. It doesn't have its own heat source. It's coupled with the boiler to give a heat input. That's why for that water heater, if I look at my boiler rating over here, there are various firing rates that are associated with the performance of the water heater. Now, this chart actually looks at the combination of storage plus recovery to meet the demands of the building. So if I know how many people are in the building and I know what size boilers attached to it, I can choose a water heater. For instance, I look at an application. There are 3 residents in the building and they have a 60,000 BTU boiler. This is the intersection of the 60,000 and the 3. I have to do the WHS 60. I'm doing a 60-gallon water heater with 60,000 BTUs of input into the water heater. Now, let's say I have that same building, but the boiler isn't 60,000, it's 100,000. All of a sudden I drop down to this point, and now I'm looking at the WH7. It is a 41-gallon water heater. So when I look at tank-type water heaters and residential applications, typically it's a combination of storage and recovery that gets me to the performance that I need. So this is a great single step, and a lot of manufacturers have charts very similar to this. Now, I'm going to stick with the Amtrol, again, because I know a lot of their charts quite well. This is you can't see most of the information on here. I'll show you a blow-up, but they also have available sizing forms or sheets based on individual types of applications. This is their Premier Series for motels. I'm going to show you a blow-up of the important information. So for motels or hotel sizing, the key point here is I need to know the number of rooms in the hotel. So let's say for an example, we are doing a motel that has 50 units. The chart to the left-hand side is utilized to size the water heater or water heaters. The chart to the right-hand side is about, let's size the heating plant to support those water heaters. So for 50 people, there's my column. I'm going to go with the 120-gallon size tank. It's telling me for a 50-person hotel or motel, I need 2 WHS 120 water heaters. Now, that's half of the solution. The other half is how much heat or how much energy do I have to put into that water heater to generate the hot water. That's where the chart off to the right comes in. So I enter the chart at the 50 unit range. I go up to the blue curve because I'm doing a WHS series water heater. I come across and it's about 400,000 BTUs. So to meet the demands on this, for this 50-room motel, I need 2 WHS 120 water heaters, and I need 400,000 BTUs of energy to support the recovery of those water heaters, the demand on the water heater. Okay. Now, a lot of other manual methods of sizing the water heater, but what we're seeing more and more is online computer programs to go provided by manufacturers to go in and size their water heaters. This is one that Bob Rohr turned me on to quite earlier this year, and it's a great representation of an online tool to size for different kinds of applications. So this is Lochinvar's lock spec, and with this lock spec I can size water heaters. And in the center here, you'll notice it gives me a wide variety of applications. And over here, it gives me the application details. Since I spend a lot of time on the road and in hotels and motels, I always tend to do motels or hotels as my examples. So I can go in here, I can select motels, and actually will break it down by the various styles. Business traveler, convention, general occupancy, resort. It gives you a description. It also allows you to select the peak time. For the application I chose, it said, okay, we're going to go with a 1 hour peak period. I can change that if my application calls for it. It allows me to put in the pertinent information for the design. How many rooms, how many motels. There's a drop down on here to select other things that exist that use hot water in the hotel. Over here's my application requirements. My elevation, my fuel type, my water temperature, groundwater, my temperature stored. I can change values. You notice here it says show formulas. It allows me to see what's going on in the background for all of the calculations if I'm wondering where those numbers are coming from. So, you know, there's a lot of information that can be pulled out of this program as you're working your way through. It allows me to select models. What am I looking for? And it gives me choices of various water heaters, various tanks, if I'm going to do a volume water heater with a tank or tanks. I can select my storage size. What percentage of storage do I want compared to the load of the system? And then down here is the information for my energy savings, cost per therm, efficiency to compare to if I'm trying to model and promote a higher efficiency, I also have that information working for me. And then it gives me a very nice printout. On the top here is the application details. On the bottom here is the middle is my choice. On the bottom here is my savings, and I can also print out all of the calculation and all the background information. So it makes it for a nice package to start with a concept and end with a specification for a water heating application. Okay. Lochinvar has it. Rheem has it. I've spent some time in here. Had been traveling with my rep Mike Zago up in the Michigan area. He turned me onto the Rheem program. It's very robust as well. A.O. Smith has one. Bradford White has one. And those I just kind of hit on a few of them to give you an idea of what's out there for a resource coming in from the various manufacturers. With anything else, there's a lot of good manufacturers, reps out there working the various product lines. They can give you a lot more information on this material than I can really cover in a 1 hour period. But this allows these are a lot of different resources to go in there, take a look at the application, and be able to come up with a water heating solution that meets the demands of the system and also stays from a budgetary standpoint. I'm not over engineering the system, making the system possibly more complicated or more expensive. Now, Mark, any pertinent questions yet? I guess not. So we need to pick a water heater. And when we start to get water heaters always come with, particularly when I look at residential water heaters, they're always going to come with 2 ratings. A first hour rating and a continuous draw. And the question always comes up, which one do I choose? What are they? Why are they different? So before we talk about the water heaters themselves, let's talk about the ratings themselves. I'm going to first start with the continuous draw. Now, why I start with the continuous draw is this is one that shows up on every single water heater, whether it is a residential tank style, an instantaneous, or a commercial water heater. The continuous draw or the continuous flow rating shows up everywhere. Now, this number represents the water heater's ability to take the incoming energy and convert it into hot water. If I look at my continuous draw numbers, and this happens to be for back to the Boilermate series, here's my continuous flow numbers for a couple of various versions of indirect water heaters that are being provided by Amtrol. Okay, now here are the various inputs. Again, this is an indirect water heater, so I need a boiler providing into the water heater to generate this hot water. These are the various inputs into the indirect water heater. I can actually calculate this continuous flow number from the input, where I take the BTUs per hour, I divide it by the delta T, or the difference between the incoming water temperature and the outgoing water temperature, and then I divide it also by 8.33. That way there, my BTU normally is associated with pounds mass, but I want a reading in gallons per hour. Okay. So if I do that, let's say I have a 4,000 BTU, 40,000 BTU boiler. I have a 70-degree rise. I take that 40,000 BTUs, I divide it by 70 degrees Fahrenheit, and then I divide that by 8.33. If you do that calculation, you're going to come up with 69 gallons per hour. 40,000 BTUs here, 69 gallons per hour here. 40,000 BTUs here, 69 gallons per hour there. It's recovery only. It has no reflection on the stored water. Continuous flow, I should be able to get this on hour 1, hour 3, hour 8, if the system is running continuously. Okay. Now, when I look at electric water heaters, this happens to be pulled out of one of the Rheem manuals. You'll notice it doesn't say continuous flow. It says recovering. And I look at the numbers here, and it's recovering at the rate of 21 gallons an hour. Now, look at a recovery like that. That's not a lot of continuous flow. So it really does more reflect recovering an electric water heater. Where does that number come from? Well, Rheem was good enough to put the formula in the manual so I didn't have to calculate it. But if I convert 4,500 watts of electricity, which is pretty much a standard electric element for a residential water heater, I'm going to get 21 gallons of recovery out of that single electrode. So when I look at water heaters, one of the performance numbers that are shown with the water heater is going to be a continuous flow or a continuous recovery number. Now, the other type of water heater rating is what's referred to as the first hour rating. First hours, you'll see it typically associated with residential style water heaters, and they're going to be of the tank variety. Okay? The first hour rating reflects both storage and recovery. Now, how is it run? It's a DOE test. Okay? So the test is started with a full tank of hot water. And for the DOE first hour rating test, the tank has to be at an average temperature of 135 degrees. How the test is run. The water is drawn off at a rate of 3 gallons per minute. And the control point is not going to be based on any sensor in the tank. It's going to be based on the outlet water temperature. So the outlet water temperature is measured, and when the temperature drops 25 degrees Fahrenheit, the draw is discontinued. At that point, the heat source is turned on and the tank is allowed to recover. When the tank gets back up to temperature, we then start the draw again. Again, if it drops to that 25 degree point, 25 degree drop in the water temperature, I start the heat source up, and then I repeat the process. And I continue to repeat that process until 1 hour has elapsed. At the end of the hour, the sum of all the hot water that's drawn on those draws during the course of the hour is added together, and that is the first hour rating. So back to my Boilermate chart there. Here's my 41 gallon water heater. We'll go with that 40,000 BTUs. First hour rating, 89 gallons. Okay. 40,000 BTUs. With an 80 gallon water, 120 gallons. It's storage and it's recovery. Okay. So when I do a residential, this is a piece of information that I can use, and when I'm sizing a storage type water tank for a residential application, because I'm calculating based on a 1 hour peak demand, I'm going to use the 1 hour rating to size that water heater. Okay. Now, when it comes time for water heaters, one of the questions is always about, from the application, am I using an instantaneous or am I using a tank type water heater? Now, we're always interested to find out what people are doing, what people have in their homes. So we're at a point where we'd like to run, what are you ready for a poll? We'd like to run a poll about the style of water heater that's currently in your residence.
Yes, in your typical application, which type of water heater is your standard? It looks like the lion's share, 58%, says freestanding tank type. 24% say indirect boiler fired. 9% say the Combi-boiler water heater. 7% say instantaneous wall hung. And then finally 2% are saying the heat pump type.
Oh, Very interesting. Thank you. So, we've already voted and we've thrown out a couple of things on there for the water heater selection. So when we start to look at water heaters, there's a lot of ways of dividing up the water heater types. The first division I want to make really is about whether I'm doing a tank or an instantaneous. Okay? Tank style water heaters, when we look at their performance, it's really based on a combination of storage and recovery. There'll be a tank of water to draw against, but there'll also be a heat source in there to recover that tank of water. Now, instantaneous. An instantaneous water heater really is all about generation. I have no storage in the water heater, and the amount of hot water I can get out of that really is based on the firing rate of that water heater. So when we start to look at these, we'll take a look through. We'll look at the various versions of each one of these, and then we'll talk a little about the pros and cons of the various styles of water heater coupled with the energy sources. Now, I kind of like to work from a baseline and work up. So my baseline for discussion today really is the tank style electric water heater. I have a cutaway drawing over here directly out of my Hydronics 11. Off to the right-hand side, I have a typical storage, electric storage type water heater. This happens to be one from HTP products. Okay. And your electric water heater normally will have a high and low element, and as you see here, there are two access plates on the side of the water heater to access the electric elements. And we're using electricity, typical residential 4,500 watts of electricity to heat the water up in those tanks. Now, about the two elements. Not only do I have two electric elements on the side, but I also have an upper and a lower thermostat to control those elements. It's all about first hour delivery, but also being able to deliver water quickly beyond that first hour. Because with an electric water heater, with electric element, remembering back to those numbers, 4,500 watts of electricity gives me about 21 gallons per hour of recovery. So it's about, once I've worked my way through the water, about quickly being able to deliver more water. So, with the electric water heater, there are two elements, but typically it's an or. I'm going to use only one element at a time. Normally, the bottom element is in use. I want to use the bottom element because I want to recover the entire tank. Why do I have that second top element? It's sitting there with its own thermostat, also located in the top of the tank. If I start to exhaust the hot water in the tank to the point where the upper element sees a drop in temperature, I want to be able to quickly recover the top portion of that tank, so over a longer period of time I can still provide hot water for other draws that occur beyond that first hour drawdown of the tank. So by putting that upper element with the upper thermostat, the water temperature drops, the upper thermostat drops out, the lower element turns on the upper element, so that I'm just using that 4,500 watts of energy to recover the upper portion of that tank. Once the upper thermostat is satisfied, it then shifts over and it brings it back down to the lower element to recover the entire tank. But that upper element's really all about providing a quick recovery of the top of the tank to take care of draws in instances where that tank has been exhausted. Now, because of the nature of being powered by electricity, I pulled up a couple of ratings here for a few of the Rheem electric water heaters. So you'll notice here's my first hour ratings, and here's my recovery. Okay, So this first hour rating is under that first hour test. And if I look at the numbers, particularly the recovery numbers, and I start to compare as we go through other methods, you'll notice the electric numbers are lower than other styles of water heaters. So what does this really mean to me? You know, I look at using an electric water heater. What are my pros and cons? You know, out of the gate, my first instinct was, well, the best thing about an electric water heater is it's electric. The worst thing about an electric water heater, it's electric. Why is it good? It's electric. An electric water heater typically has the lowest upfront cost. It's also all self-contained. So what I'm really doing is I'm bringing water and I'm bringing electricity to that water heater. There's no burner. I don't have to worry about the burner. I don't have to worry about an open flame or any combustion wherever the water heater is located. Additionally, I don't have to worry about makeup air for the combustion process, and I don't have to worry about a flue to get the combustion products away from the water heater. This, coupled with the fact that there's no flame, gives me great flexibility in the location of the electric water heater. I've seen electric water heaters in mechanical rooms. I've seen them in bathrooms. I've seen them in kitchens. I've seen small ones under counters. It gives you great flexibility in where I can put it, because it's just about where's the water and can I get electricity to it. The cons, you know, everything has an upside. Everything does have a downside. Okay? Because I'm running off of electricity, typically the recovery rates are going to be lower with an electric water heater as compared to the same volume water heater that's being recovered by other methods. Okay? Now, because of the lower recovery, typically I see an electric water heater going into an application that's larger than a water heater fired by another method. You know, up through New England, and we're going to talk about indirects, historically, I've seen a lot of 40 or 50 gallon indirect water heaters. If I look at what I've seen for electrical, usually I see a lot of 75 gallon electric water heaters, trying to overcome that very low recovery rate. Now, electric water heaters have great energy factors, or EFs, because they're well insulated, and you know, there's no, the losses are minimal, and the resistance process is pretty much 100%. So you end up with real great energy factors. However, in a lot, if not most markets, typically from a unit of energy standpoint, you know, you see that electricity is much higher than, I'll use natural gas as a for instance. So the energy needed to deliver the hot water that building requires, a lot of times you may find that your electrical water heating costs are probably your highest cost month in, month out of any method of generating hot water. But it has great application. It certainly has, you know, specific places in the market where it does become a very good choice. Now, this one, I believe on our polls, only got 2% vote for the hybrid water heater. To me, I think it's probably one of the most cool products we have there on the market. And it's a specific version of an electric water heater. It's a combination of a heat pump and electric resistance. So if you look at the picture over here, I still have an electric element here. That's why it's hybrid. It's resistance, but it's also heat pump. But I have a heat pump sitting on the top of the water heater, drawing air out of the space and extracting heat with that heat pump from the ambient air and allowing it to heat the water in the tank. Okay. Now, a couple of things about this. When I look at a heat pump water heater versus an electric water heater, because of the heat pump component, the initial costs are a lot higher for a heat pump water heater than a straight electric. I should say a hybrid water heater. However, we're finding that many electric utilities, because of the efficiency, there are some pretty decent rebates on the hybrid water heater. The performance from an efficiency standpoint is outstanding. Okay. depending on the brand and the setup of it, this happens to be Rheem's number, I can get an energy factor up to 3.5. So for every kilowatt of energy I'm utilizing, I'm getting the equivalent of 3.5 kilowatts of energy as heat deposited in the water of my tank. Now that's an outstanding number. That's why they're heavily rebated. Now, the thing with this application, I have to pull that heat from somewhere. Typically, it comes from the air in the basement or the mechanical room. How much heat am I pulling? Depending on the delta T or the temperature rise, if I got a 50-gallon water heater, let's say it requires about 30,000 BTUs of energy to recover that 50 gallons. That energy has to come from somewhere. It comes from the air in the mechanical room. It comes from the air in the basement. So there is a volume requirement of the space that I need to have a minimum volume of the mechanical room to pull that energy out for the hybrid water heater to be a viable product. The other thing that happens is because I'm pulling that heat out, what you typically will find is the hybrid water heater will lower the temperature of the space the water heater is sitting in because of the fact that it is pulling that energy out. I don't have it on the slide, but I'm going to throw this on this in the discussion as well. Being a guy that has a damp basement, the hybrid water heater, because it's pulling that energy out, also is pretty efficient at dehumidifying a wet basement. So that is something to consider. Also, it means that when you're doing a hybrid water heater, you also have to consider the condensate that's forming inside the heat pump. So you have to effectively dispose of that condensate. So a couple of things to consider. But from an aspect of electric water heater, it becomes a very interesting offering. Now, here are the performance charts for the Rheem unit that I had on the previous screen. So if I look at my temperature rise, I'm going to look at my recovery. My recovery now is 29 gallons per hour. Better than straight electric, not quite as good as going to a gas burner, but from a performance standpoint, it's pretty hard to touch the efficiencies that you see from a hybrid water heater. Now, let's move on to gas. Okay. Here's a couple of pictures of various gas-fired water heaters. Here's the cutaway of an atmospheric one, and this actually does a good job of mimicking what we have over here from Lochinvar. So I have a gas burner on the bottom. Here I have a central flue, and what I'm doing is I'm bringing my fuel into the water heater. I'm burning the fuel, and then through the flue, through the bottom of the water heater and the flue, I'm extracting the energy. Now, with a gas-fired water heater, my recovery numbers are tied to the firing rate, and I can get much more energy into a gas-fired water heater than I can electric. So here's a typical chart. This is a 29-gallon Rheem water heater with a 60,000 BTU burner on the bottom. I get a recovery number of 61 gallons per hour. From a 29-gallon water heater, I get 90 gallons first hour rating. These are really outstanding numbers. So all of a sudden, when I start to bring that gas burner into the equation, I start to see the performances start to go up. Same thing happens on the commercial side. Okay, this is a Bradford white chart. This commercial EF series is actually the water heater that's being shown off to the left. I now am looking at a 60-gallon water heater with 125,000 or 199,999 BTUs. A 100-gallon water heater, I'm going to round up 400,000 BTUs. And with that kind of energy, I'm looking at first hour ratings at 100-degree rise of 451 gallons for continuous recovery on that water, my continuous number. So when I start to bring that gas burner in, all of a sudden my recovery numbers can start to become much more dramatic, much larger, and I really don't have to rely as much on storage. So I throw in the gas burner. What does it get me? Well, the pros. I'm still in a self-contained water heater. In most cases, compared to a few other options, my costs are still fairly low up front. And due to the nature of the gas-fired water heater, I have some much higher recovery rates available. Now, the other pro is if I'm comparing it to electric, in most markets, my energy costs, even though the electric water heater has a higher energy factor, I'm still going to be in a better fuel savings or a better gallons delivered per energy cost spent with a gas-fired water heaters. The cons? Well, I'm concerned with makeup air and venting. It's a gas-fired appliance. Additionally, depending on the style, I may have higher flue losses through that flue. That tends to drive the energy factor down low. Also, when I start to look at what I need for firing it, there's always the need to bring the fuel in. And I didn't put it on here, but depending on the style, then I have to be concerned about non-combustible floors. There's a lot of things that come into play when I move from electricity to gas. The other style of tank-style water heaters is what's referred to as an indirect. I'm showing two models there, the Amtrol Boilermate and the HTP Superstore. I tend to show those two because I think most guys that have started and had got into indirect water heaters in the 20 years ago when they really started to hit the market, these were probably the brands that they probably cut their teeth with. It's referred to as an indirect. You have a coil in the water heater because the boiler does not contain its own heat source. I have a coil that I'm going to connect up to the water from a boiler, pass that water through the coil, and by passing it through the coil, I'm going to transfer the heat from the boiler into the water heater to heat that water up for use. Now, when I look at sizing and I look at performance, it's not as easy as a lot of times as a gas or an electric-fired water heater for what I can get out of it. Because that water heater doesn't have any contained heat source, there's a lot of things that recovery is based on. The first item is really it's based on first the boiler firing rate. How much heat is that boiler putting out? This sets the maximum number. Now, just because it is the maximum number doesn't mean that's what I'm going to get. The actual recovery is really tied to two other factors: the flow rate through the heat exchanger and the water temperature flowing through that heat exchanger. So when I look at performance, I have to look at the chart from the manufacturer to make sure I meet all the conditions to get that water heater to recover to my requirements.
Jody, this is Mark.
Yes.
Hey, this might be a good time for one of the questions that came in as it relates to indirect hot water heaters. In these situations where you have a building that has both a domestic hot water demand as well as space heating, and recognizing that in the summer, typically your boiler is not doing any space heating, what are the main impetuses for a combi boiler versus, or I should say indirect hot water heater versus two standalone units?
That's a very good question, and that's actually something that a lot of people wrestle with. I like the idea, I like using back to everybody's biases. One of my biases, every house I've had an indirect water heater in, but I'm also in a boiler market. So where the indirect really starts to show value, particularly in the middle of the summertime, well, first off, usually the big concern in the middle of summertime is when the recovery finishes, the indirect is hot, but the boiler is also hot. And the thing is, there's that heat in the boiler really is not going to a use, it's going to losses. So when I start to look at the summertime with the indirect, the first thing that I want to do is I want to use a control that will purge all the energy out of the boiler and into the water heater. And in most cases, maybe 2 to 5 minute time period, for a larger mass boiler, I should be able to extract all that energy out. If I'm doing a condensing boiler with a small volume heat exchanger, let's call it 3 gallons or less, I'm probably going to pull all of that energy out of the water heater in maybe a minute time period. But what it does is it allows me typically to have a much higher recovery rate through the summertime or the wintertime than a standalone water heater would. Additionally, the other reason that another big plus about it is the fact that I only have 1 unit burning fuel. So if I'm looking at makeup air, my makeup air is all based on just the firing rate of that one boiler rather than the combined. If I'm going sealed combustion, there's only 1 makeup air coming from the outside, 1 exhaust going to the outside as well. And from the aspect of the contractor side of things, a lot of guys like having the indirect with the boiler because the boiler is running all summer long. It's not that at the beginning of the heating season, all of a sudden this boiler has sat idle for 6 months and now I'm trying to get it to go and there might be issues. It's run the entire season long, so that when that heating season starts, it's not something that all of a sudden is called upon to work and then the issues rise up. Hopefully somewhere in there, by the way, was the answer to your question, because I kind of rambled a little bit on it.
No, that was great. I think it gave a lot of input and factors to consider. And I hope you don't mind, perhaps right here is a good place for 2 more good questions that came in, because I think they apply to whether or not it's a freestanding self-contained unit or indirect like this. First of all, if let's say that our application required capacity such that we want 2 tanks instead of 1, is it better to typically plumb those tanks in parallel or in series to get the most efficiency?
From an efficiency well, actually, are we talking efficiency? Are we looking at what's going to give me the best delivery or the best efficiency? I guess is the question. What were they asking about? Which side were they asking for, Mark?
Well, basically asking which is the best way, so I guess you can approach it either way, efficiency or capacity.
Okay, if I'm looking at it from the capacity standpoint, I want everything in parallel. And in most cases, rather than going parallel, I'm going to make the flow rates even. I'm probably going to pipe them in reverse return. That way there, both water heaters see the exact same flow rate, the exact same water temperatures, and I can recover and draw the 2 tanks down as a single tank. Now, if I go in series, and this is kind of coming back to I'm going to kind of shift over to put my condensing boiler hat on. If I can go in series, I can then run the water through one water heater, then run it through the other, and set it up so that rather than the water going out to the water heater, goes out and comes back with, say, a 30-degree delta T. If I go series, I may have the option of increasing my delta T up to 60, which will drop it will increase the efficiency of that condensing boiler, but from a performance standpoint, it's going to be minimal gains as compared to doing the 2 tanks in parallel.
Okay, it's a good point, and that's a typical application for a solar assist hot water heater system 2 tank. You're typically going to be in series, correct? So that you can maximize or lower the temperature going back to the heat exchanger, the solar collector heat exchanger, that is.
Exactly. I've also seen instances where they've done a 2-tank system, both hydronic, utilizing 1 tank as a preheat to maximize the boiler performance. Now, you said you had another question as well?
Yes, on this, if you want to increase the capacity of hot water available and not change your tanks, you can use a thermostatic mixing valve. Take your temperature water in the tank up and then mix it down, and therefore, in theory, or maybe even in application, increase your capacity. Is this truly the case, or do you run the risk of higher temperatures in your storage creating standing losses that offset the efficiencies gained?
That's a very good question, and the answer is yes and yes. So if I look at this application here, that if I store that tank, if I'm looking to deliver the water, say at 120, and I look at what's downstream here with no mixing valve, this becomes a 1-to-1 ratio. 1 gallon here at 120 will give me 1 gallon here at 120. But if I increase the water temperature up to 140, 145 in the tank, and I put in a mixing valve, and I set the mixing valve to deliver 120, if I'm drawing 1 gallon here, and I'm not going to do the calculation because I might lose it on my phone, but let's say 1 gallon here, or I should say 1 gallon of hot water delivery here may only be a draw off the tank of 0.75 gallons. So I've effectively extended the performance of the water heater. Now, on the flip side, if I do increase the temperature, I do increase my standby loss. So I really have to take a look at the insulating qualities of the tank. It may be that the tank is well insulated well enough that I have a minimal increase. But I'm going to say if you look at what I can see in the extended performance of the tank versus the increased losses, the end result is I am going to get more hot water out of that tank if I apply it in that manner. All right, Mark, I think we're going to roll along here. We're closing in on that 1 hour period.
Sounds good, and probably for the listeners, we'll likely go after the 1 hour period because we got a lot of people that I think are getting questions in here, and we'll try to get to them as long as people stay on.
Yep. So this is a very specific style of indirect water heater. I'm sure a lot of you have seen the Turbo Max. That's the tank off on the right-hand side. So standard water heater, normally the domestic water is in the tank and the boiler water is in the coil. With this, it's reversed. The boiler water is in the tank and the domestic water is in the coil. It's often referred to as an instantaneous indirect. I bring the water through the water in the coil through that hot tank of water. I am heating the water up as I'm using it. So there's very minimal storage of water in the tank. Okay. Now I'd say its biggest advantage to me really is the fact that a standard water heater with a coil with water, I'm depending on natural convection or some movement naturally within the volume of the tank to turn that tank over, because the heating element's in the bottom. The coil in most tanks in the bottom, so I have to turn the water over to recover the entire tank. On the tank side with the boiler water, I am forcing that movement, and I'm always bringing the hottest water to the top of the tank. So from a performance standpoint, I'm still tied to the firing rate of the boiler, but for certain applications, this may be a great option. And again, I'm going to pick it up a little bit. I'm going to kind of skip through that performance chart there. Okay. Now, indirect fired water heaters, my bias kind of shows up that I only found one con in it. So typically, from the pluses on it, it's usually a high performance water heater based on the boiler that's selected to couple with the water heater. And typically this is the boiler that's going to be sized for heating of the building, the space heating need. The nice thing about it also is most of these boilers have a built-in control, so there's minimal amount of other components needed other than typically the circulator to move the water between the boiler and the tank. And it becomes really an integrated appliance, both space heating and an integrated system from an aspect of both space heating and domestic hot water. Of course, the one con on that side is it does require a boiler. And I'm sure somebody that's not biased like me would come up with 2 or 3 others. Now, let's talk about instantaneous. Let's get away from the tanks. So an instantaneous or instantaneous fired water heater. There's a typical one through HTP. And with these, whether it's gas or electric, there is no storage. It's all about recovery. Okay. So when I look at these and I say how much hot water, it's really about the input. Here's a formula that's directly out of Hydronics 11, so I can calculate it. If I know the firing rate of the instantaneous, the efficiency of the instantaneous, and then the delta T, how much am I trying to heat that water? So here's an example out of there. So for instance, if I have an instantaneous water heater that's 150,000 BTUs and that is 90% efficient, and I want to raise the water temperature from 45 to 120 degrees Fahrenheit, I do my calculation, I'm going to get 3.6 gallons per minute. So it's all about firing rate. Okay. What's the advantages? I think when we look at the numbers, I think the Tankless was a little bit lower on the scale of the people that are using it, but again, it's all about application. It has very little standby loss. It has a small footprint. Normally, that small footprint is going to be mounted on the wall. So there's applications where this is your absolute best choice. Okay. What are the things that have to be considered? It's all about firing rate. So when I start to look at higher flow rates, I need to have a higher firing rate to support it. Okay. Now, the unit doesn't fire. The unit fires every time somebody uses hot water. So if somebody goes in the kitchen and opens up a faucet to wash their hands, the instantaneous water heater, the tankless water heater has to fire. So you can all have this thing doing a lot of shorter cycles if there's a lot of periodic water usage, say like in a kitchen on Thanksgiving. The other thing that I hear from people that have utilized the instantaneous water heater or the tankless water heater, the process is all started by a flow switch. There is a minimum flow requirement to fire the unit. So if I open up a faucet with just a trickle expecting hot water, I may not meet the requirement for hot water. Now, commercially, we're going to shift over to a volume water heater and couple it with storage. To me, this is a really great option when I start to look at commercial water heating applications. So it happens to be I pulled that out of the Lars Neotherm manual. Here's my water heater, my volume water heaters. It could be 1, it could be 2, it could be 4. Here are my storage tanks. It could be tank, it could be tanks. It gives me great flexibility in building a system. I can look at what I need for generation and I can look at what I need for storage and couple the best of all worlds together. Additionally, from a space standpoint, I can put these in the mechanical room, the individual components where it makes best sense for the layout. For me, it's all about delivery, and it's all about flexibility. Okay. Now, the picture to the left, I borrowed off of Lochinvar's website. They also, in another number of manufacturers, have pre-packaged units. So this is a pre-packaged unit with 2 volume water heaters and 2 storage tanks. And again, I'm going to look at it really from the positive side of things. It provides the ability to match the firing rate with the needed storage for the application. I'm not locked into a water heater and a burner being a set combination. It gives me flexibility to meet the draw requirement. I have 2, 3, or 4 water heaters. I can stage them. A lot of these are modulating, so it gives me a good adaptability to best meet the needs of the system. And because they're not packaged all in a single unit, if there is a failure that I have to deal with, they're not in a single unit that I have to replace the entire unit. It's about replacing the part of the water heating system to meet the needs for water heating. Now, another specialized version of the instantaneous water heater, the Combi-boiler, and I think those actually got pretty good scores on our survey. So I happened to pull this off of IBC. This is for their DC series. So it's a boiler and it's a water heater in a same package. Most of these packages I'd say are wall mounted. So in this red square out here, coming from here and here on the boiler, that's my space heating system. Coming off here and the two center connections and into this small square down here, this is my water heating selection. I was kind of iffy about the mixing valve that they had in their diagram, so for my picture I decided to assist them by throwing in a Caleffi 521 series mixing valve. But it allows me to approach the water heating and the space heating from a single package. What do I have to be concerned with? I do have to be concerned with how much hot water I can get out of these. You know, looking across the board at what's out there, there's a lot of these that have a low firing rate. So this happens to be from Viessmann's Combi Plus kit that goes with their Vito Dens 100. It's very similar to what you see here from our Idronics, but this 26 series, that's about a 90,000 BTU boiler. And with 90,000 BTUs, my continuous number is 156 gallons per hour. That's a little bit more than 2.5 gallons per minute. So when I look at the application, I do have to make sure that when I get it down to a gallon per minute standpoint, it will meet the needs of the application. But from a supporting the application, it's great and it's a small package. So I'm doing condos, I'm doing apartments, I'm doing townhouses, I'm doing applications and we're trying to fit everything into a closet. Here's my boiler, here's my water heater in one tight package. It gives me a small footprint, and because of the way the hot water is being generated, it may be a heat exchanger integral to the boiler's main heat exchanger, or it may be a brace plate heat exchanger like you see here in this drawing, but I also have very minimal standby losses because I'm not storing a whole lot of water. On the negative side of things, the performance is based on the firing rate. There is no first hour boost that you normally would see with a storage type water heater because of the tank. So I have to pay attention to my sizing. Just as within a dedicated instantaneous water heater, it fires every time there's a need for hot water and there is a minimum flow. But for an application that I have to get it all into a small space, you know, the combi boiler is a great option, and it's definitely a segment of the market that's growing. Now, kind of to wrap it up before I pass it on to Mark, we need to talk about hardness, and that's one of the things I see as I start to looked at various manufacturers' literature. They talk about hardness, they talk about how hard the water they can be, and then additionally they talk about how scale resistant their water heater potentially is. So let's talk a little bit about it before we start to wrap this thing up. So why am I worried about hardness? Hardness is about water, and I'm going to primarily stick with calcium bicarbonate. So calcium bicarbonate is in the water, and what happens is when I heat that water up, you can see this picture here. What this is a cutaway of a copper tubing that was part of this. This is called the tankless coil. It's something that I didn't even touch because it's so old school. It's a coil that sits inside a boiler, and I pass the water through the coil to generate hot water. If the water is hard, because of the increase in temperature, that calcium carbonate comes out of solution as insoluble, the calcium bicarbonate comes out of solution as insoluble calcium carbonate, coating the surfaces of where that heat transfer has to happen. So how much happens? Two of the factors, the level of hardness and the amount of daily water usage. These are things that I can't adjust. Well, I can adjust the hardness if I soften the water, but these will have an effect on how quickly the buildup happens on the heat exchanger surfaces of my water heaters. Another factor is the water temperature. If I'm heating water to 125 degrees Fahrenheit, the buildup is going to be slower than if I'm heating that water in the tank up to 160 degrees Fahrenheit. The higher the water temperature, the lower the solubility of the calcium bicarbonate, the more is going to come out of solution and problems are going to occur faster. So if I can store cooler, if I can store at a lower temperature, I am going to see better performance. Then it becomes about design. If I can keep my water velocity up, and that tends to look more at your instantaneous style of water heaters, I can reduce the amount of buildup. It's about pushing the flow so it's turbulent. The turbulent flow allows the water essentially to scour the side of the piping, and from my aspect, it's about removing the boundary layers, because in the boundary layer with laminar flow, I tend to have a much higher temperature. I get the velocity up, I scour the boundary layer, my overall, my surface temperature becomes less, the buildup is reduced. The other thing also is if it's a good smooth surface, it will also try and help whatever hardness comes out of solution help keep it from plating on the water heater itself. And then it's about the surface temperature. The hotter the temperature, the higher the buildup. Okay, so it's about dropping that temperature. If I have a heat exchanger that there's flue gases, combustion gases on one side, running at 1300 degrees versus a lower water temperature, say I'm doing an indirect with 180 degree water, that hotter flame supported heat exchanger tends to scale up faster. It's about the size of the heat exchanger area. If I have a much more compact heat exchanger and I'm trying to pass the same amount of heat through, my heat flux is higher, causing a higher surface temperature on the water side. Higher surface temperature, a higher scale buildup. And then I'm going to come back to the water velocity. Again, if I can keep my water velocity up and I keep that turbulent movement, it's going to help mix all of the water in the water heater, in that channel in the water heater, to again help try to minimize that surface temperature, to help minimize that buildup. But from the aspect of the scale buildup, there are certain things that are tough to work with, but when I look at the design and the application, there are things that I can do to drop that scale buildup to something that might be a more reasonable level. So,
hey Jody, back to that last one before you wrap it up. A couple other points came in. Of course, you wouldn't have scale buildup if you incorporated a hot water heater to treat the water. And of course, the downside of that is increased sodium in your water, which doesn't taste so good.
Yep.
And the second thing is it makes the water more conductive, and so which means that the tank could be more prone to early corrosion than if you didn't soften the water. And this was also a point that was brought up, a very good point, when someone observed how to increase the capacity of heat in your tank by using a thermostatic mixing valve and taking your temperature of water up. Yes, that's very effective, but yes, even taking your temperature of water up also increases the corrosion potential in your hot water heater, and at a minimum will consume your anode rods much quicker. So a couple of good points that this slide, I think, allows us to address with those questions that came in.
Oh, absolutely. So, actually, do we have a poll that we're supposed to run at this point?
In your professional experience, what's been most problematic with water heater performance? We'll share those results. It looks like the winner here is 31% says insufficient hot water production capacity. 26%.
Really?
Yes, and 26% right behind that is excessive lime scaling. 18% water leaking. And then at the bottom, 12% each for energy cost exceeding expectations and controls malfunction.
Oh, that's a very interesting. I thought it would actually be leaking would have been the number one. All right, so kind of wrap it up. I'm going to come back to my first slide. So when we start to look at, we started this discussion. We talked a little bit about how much water does the building need, and it led into the methods of water heating sizing. We looked at a couple of ways of doing it old school from the paper size method. By the way, a little side note: the Hunter's curve method of sizing water heater is under examination because it has been around since 1940, and I know a couple of groups are looking at updating it to more reflect what we have now for fixtures and usage in this current day. And again, we looked at a lot of them, kind of looked at one at depth and then kind of scanned across a couple of other manufacturers' websites. A lot of great resources out there for sizing of water heaters. Then we made our way through the different water heaters, talked about the storage water heaters that give us a combination of storage recovery, talked about the instantaneous, and kind of contrasted as we made our way through. And I'm going to leave this up here, and this is something that will be debated probably till the end of time. So, what is the best method to heat water? We all have our opinions, and from our earlier discussions, we all have our preferences.
Jody, how about two more questions? Is that okay?
Oh, absolutely. I got nowhere to go.
Okay. All right. Okay, there is some questions concerning the differences between peak time and first hour. For example, you showed one of the manufacturers that has an online sizing program, I think it might have been Lochinvar, that indicated that more than 1 hour could be chosen as your peak hours. And the first question is, it's assumed that if it's 2 or 3, that those would be consecutive hours, and then is that true? And then secondly, how do you determine peak and what does it mean?
Well, I guess to the first point, typically when so when I start to look at the website where you can choose different amount of hours, when you start to look at applications, for instance, when I look at hotels and motels, a business traveler hotel is probably going to have a 1 hour peak. But if I look at a resort hotel, in a resort hotel, it's not like, the people at my hotel last night, I'm in Milwaukee, Wisconsin. It's 0 degrees outside. There's not a whole lot of tourists moving around. They're pretty much there for business. They're up, they're showered, they eat, they're out the door. So you end up with a very short, a very concise peak that's going to occur. I'm not sure the exact number, but I do a resort, and all of a sudden that peak may not be over a 1 hour period. That peak may be over a 2 hour stretch. By the way, if I start to stretch that peak out for the same amount of fixture units, or I should say for the amount of water demand in the building, all of a sudden my requirements may drop down. So it's very specific to the application. And you'll typically see it more on the commercial side than residential. So on the residential side, the water heater, the first hour demand number, that normally, or the first hour draw, the first hour rating, that's associated with the water heater. So what I'm trying to do is I'm trying to match the rating of the water heater with the peak demand of the building. And residentially, typically we're looking at a 1 hour peak. So it's about requirement versus performance of the water heater. So you have a peak and you meet it with a first hour recovery number for that water heater.
Oh, that's a good clarification. Thanks. Second question, you showed some manufacturer charts and tools showing amount of hot water consumption depending on the application. So as an example, showers and the like. Mm-hmm. How do those numbers from manufacturers typically, if you know, compare to ASHRAE ratings for similar applications?
I'm not sure the exact background information on a lot of this material. I'd say a lot of things. For instance, the chart that did end up from our Hydronics 11, I know the numbers that we showed for peak usage for different type of hot water usage in the building were actually pulled from the Department of Energy numbers for that that application. So the Department of Energy, for instance, said your typical shower will utilize 12 gallons of hot water.
Okay, I think that's, we got one observation here. It was a clarification, or a not so much a clarification, but when you clarified the advantages of using an indirect with one boiler driving hot water production as well as space heating, one of the things that you wanted to make sure, if you could, was to make sure standing losses in the boiler get utilized, and so at least a couple of manufacturers had indicated that that's what they do, including putting or recommending the tank sensor placement into the indirect up a ways, so it allows the capacity for a few minutes of post stop purge, so that the cold water does get flushed out and the hot water from the boiler or heat from the boiler does get utilized and stored in the tank rather than being sent up to the flue. So that was some good verification from some of the folks that were listening in from the manufacturing standpoint.
See, Mark, what I was going to go with on that thought is if they utilize a Caleffi zone control, you could utilize the post-purge feature in the zone control to make that happen as well.
There you go. There's more than one way to skin a cat.
Oh, there absolutely is.
And I think that's it, Jody. It's 1:30, so I want to, on behalf of Caleffi, thank everybody that listened in today. Be on the lookout for us on the next webinar. And Jody, thanks a lot for a great job. Appreciate it.
Oh,
and we'll see everyone else
I enjoyed it
soon.
very much.
Thanks, Jody. Bye, all.